Tom, I had a question. Laughter or humor doesn't seem to have an obvious basis or reason, at least that I can discern based on evolution, to be part of our physical makeup. And it almost seems to be sort of an anti-ego reaction. You know, it's like you're taking yourself too seriously. Does laughter come from our spiritual side? And or, as a follow-up, are there any other everyday experiences or emotions that people can relate to that would be, you know, mostly from our spiritual side?
Well, yes. I think you'd put laughing and crying both into that same category. If you look across all the cultures everywhere, no matter how limited they are or whether they're in the middle of the rainforest someplace or whatever, they laugh and they cry. That's kind of two things that people do. And when they do that, it's actually kind of a similar expression. It's kind of jerky diaphragm, you know, where there's laughing and crying both. There's different facial expressions. They're two similar things. And it's the way that consciousness expresses something that is completely non-intellectual. We can express things in words. We can describe feelings in words. But if you really want to express a feeling, a strong feeling, there are no words, you know, to say, okay, now I know I can express a feeling, but this one's going to be a real strong feeling, so listen to my words carefully. You know, that doesn't work. That doesn't work. You need something a little more dramatic and something that's a little more direct being level. So the laughing and the crying are both being level expressions, not intellectual expressions, whereas the language is an intellectual expression. And sometimes an intellectual expression just won't do. It doesn't let us express ourselves, our feelings. And it's not even so much communication as it just is expressing how we feel. So the laughing and the crying, yes, come right out of the need of consciousness to express a very deep joy or a very deep sadness. And it's interesting how they both are very similar in their biological, you know, what they do and how a person acts. Not a whole lot of difference between them. Whether the lips are kind of curved down or curved up, you know, is about the only difference. The rest of it's all pretty much the same. The feelings are quite opposite, but the expressions are very similar. Yeah, definitely out of consciousness. There's no need for biology to create that. You know, there's no need for the rule set to create that. It's not part of our survivability or our procreation. It's basically out of a need for consciousness to express itself in some way other than intellectual. Kind of like body language, but an extreme body language.
Great. Okay, thanks.
Hey, Tom, question for you. When you first started, I guess, downloading this theory or this, I'm kind of curious about your first initial experiences where you were out in non-physical, gathered some of this info, and then brought it back and could cohesively describe it. Kind of like what occurred in the meditation. Did a guide come bring you down a portal? Or I know everyone's experience is different, but I'd just be curious to hear.
Okay,
like,
sort of how did I end up with all this information? What's the process
Smart
of
man,
gathering it? I didn't get any of it directly told to me. It wasn't like I was told the answers and all I had to do is go write them down. It didn't come like that at all. It was my own experience, my own experimenting and exploring around in the non-physical that answered my questions. And my questions were basically questions of a physicist who'd like to know, how does this thing work? So I had all these experiences, but I couldn't really make good sense out of how did it work and how was it consistent with everything else, particularly with the physical world, with science, with everything else. What's the theory that ties it all together? So this was a major question, and I would try to find those answers out, not by asking the question, you know, how does it work? Because that doesn't work. It was better for me to just experience. For instance, it took me months to figure out that the databases were databases and not just some other kind of reality going on. We discussed that a little bit at lunch. What I realized that the information that I could get, information defining auras, information defining what people were feeling or thinking or what was going on in some other remote location, I experienced being able to get that kind of information. And then it got easy to where I could get it quickly and easily at will, and generally it was very correct. So the question is, how did I do that? Where did that information come from? And there was ideas then about multiple realities, like the many worlds. There's all these realities going on at the same time, and you're just jumping back between the various realities. And all those ideas were kind of theories, things that could possibly be true. I just needed to do the research to find out what was true and what wasn't, what worked and what didn't. So I pretty well pieced it together from my own experience and my own analysis of that experience. And interestingly enough, I didn't see the biggest picture until after the books were written and were had been on sale for a couple of years. They were first published in 2003, and it's probably more like 2004 or 5 that it occurred to me, and it should have occurred to me sooner, being a physicist, but it occurred to me a couple of years after they were published that the very same concepts that I was using to describe consciousness, metaphysics, how, what the world is, that it's virtual and all of that, suddenly it occurred to me that these were perfect descriptors of what's going on in quantum mechanics. It's exactly the same. And then I realized that virtual reality explained quantum mechanics. That if you really understood how virtual reality worked, you'd understand how the whole world worked. And that made it pretty clear to me that it was a virtual reality, because if it does good physics, then that gave me a lot warmer feel that it was higher, more likely to be an accurate model, a good metaphor for the model. So I got a lot of warm fuzzies from that, because there's lots of people, 2,500 years ago, the Buddha said, this is all an illusion. Well, it's the same as saying it's a virtual reality. And there's lots of other people who have come to similar conclusions. Lots of people understood a lot of things about the spiritual world, about the purpose for us being here, love is the answer. These things have been around a long time. But none of these philosophies, none of these ideas ever explained quantum mechanics or relativity or did good physics. They were always over here in the metaphysics poetry side, and science was over here in the objective physical world side, and those two sides had a wall built between them, and they didn't overlap. And I was doing my work over here on the consciousness side. It was more metaphysics than science. Yes, there was some science and there was some logic in it and so on, and all that's sort of in the book, but it mainly was like a theory of consciousness and reality. And then to find out that this theory of consciousness and reality is also a really good, understanding of physics. It does better physics, and that I could explain most of the mysteries of physics. What do we call those? Paradoxes. Physics has a whole lot of paradoxes in it, just things it doesn't know. Fundamental things. What is time? What is mass? What is space? Where do these things come from? What's the origin of this? Well, these are real basic things. I mean, that's the basic fundamental down at the roots of physics, is what is mass, what is space, what is charge, what is spin. They don't know. They just are. Well, they just are is not a good answer if you're a scientist. That's mysticism. It just is. So at the very root of science is mysticism. They have a system that has no explanation. Well, that was kind of an interesting thought, that's the way it was. And then I realized that virtual reality had the answer of how things just are. That explained that. It gave a rational reason. Well, they're just calculations. They're in I've done lots of simulations. I did that for a living for many decades, where you make simulations of things. And I modeled mass, and I modeled space, and I modeled all those things. They were just numbers in a computer. Well, there you are. That's where they come from. There's nothing, they have no cause which is a problem when you're a materialist and everything has to have a cause, and none of those fundamental things in your science have a cause. That's troubling. But they don't need a cause in virtual reality because the virtual reality is just computation. It's a rule set, and you compute it. So how do you create space? You put an origin someplace and define a set of three, orthogonal vectors. That's space. Space around that origin. That's what you do in a simulation. And that's the whole definition of space. So how could the universe keep expanding, even accelerate its expanding? The numbers in a computer. What's it expanding into? What was there before it expanded? It's not a good question. It's just numbers in a computer. There wasn't anything there before it expanded. It was just potential space before it became real space as the numbers got bigger and bigger. So it kind of, space is created in a computer. So it gives those sorts of answers. So I figured all of it out and wrote the books. I didn't figure it out quickly though, from my work at Monroe in the early 70s. I didn't write these books, I didn't publish them until 2002. It was a long time between 1970 and 2002. And I basically was working on it all that time, trying to figure it out. So it was a slow process with a lot of detailed analysis and experimentation on my part to try to answer the questions of how does this thing work? And eventually I got the idea that it was just information, because that just, you think about it, that kind of comes to you. Everything is information. Our sense information defines this reality. Well, it's really a data streams defining this reality. So once you realize it's just information, it's an easy step to go to, it's a virtual reality, it's computed. That's what information is, right? Information, the smallest piece of information is defined as a bit. So information and bits kind of go together. And then after we got to digital information, a lot of other things started to fall into place. So it was just a long trip. And what I used the non-physical for was doing the research as to how the fundamental reality worked. That the databases were just databases and weren't actually other ongoing realities with free will in them. You just have to do the experiment before you find that out. So that's not written anywhere. Nobody else has ever said that. It's not like you can get that. The Buddha didn't talk about virtual reality and where the information is stored and where it's coming from, because those weren't concepts in that day. Nothing that could be said about it. So it's just been a long time, just kind of noodling it out and then testing it and seeing if that works and then thinking about it some more and making it a little better. And did I get some nudges sometimes? Sure. Sometimes I'd be pondering over a problem. How could that possibly work? These two things are in conflict, and I'd think about it, and yes, sometimes I'd get some ahas. Oh yeah, that would solve it. That's a good idea. And then maybe that good idea would solve 3 or 4 more problems too. So those things happen, little aha moments, and I wouldn't say that they're all mine. Some of those may have been nudges that I got from the system.
Like a whisper in the ear?
Yeah, like a whisper in the ear. I didn't get it that way. I just get kind of a understanding, see the connection, see suddenly how different things connected. So it was a long process of me figuring it out. It wasn't me taking dictation from some non-physical source. Although sometimes that process happens, but when you're a physicist, it doesn't happen. That's not the way I think. It's not the way I work. If I don't understand it, and if I don't derive it from basic principles, then it isn't mine. And if it's not mine, I'm not going to write about it, and I'm not going to tell other people. I can only stand up and tell you about it. I can only write the book and publish it because it's mine. It's my experience. It's what it's based on. If it was like, well, this is what they told me, that's not a good argument for a physicist.
Tom, I just want to ask, if I were a classical physicist and I'm trying to relate to what you teach in My Big Toe, how would you explain, with your theoretical system, how would you explain the Einstein-Podolsky-Rosen effect and quantum tunneling, for example? What would you say about that is explained in your system that scientists have no idea what's going on there. I mean,
Sure, they don't. They have no idea. One of the things the Einstein, Podolsky, Rosen had to do with what's now called quantum entanglement. Okay, and the other is a phenomenon called tunneling, where particles end up places they shouldn't be. And there's real good explanation of both of those. And what I would tell this physicist would be, if you think about, if you understand virtual reality and how virtual reality comes about, it comes about from a random draw from the probability distribution of all the possibilities. Okay, so let's say we're going to look at something for the first time. And a good example would be, let's say I'm going to look into a piece of outer space that nobody's ever looked at before. So when I look out there, what do I see? What's going to come through my camera that I'm going to take a picture of in this quadrant of space that nobody's looked at, because I've got the neatest, latest telescope that can see farther than anybody else? Well, what the system does is it looks at all the possibilities of what could be there. Now, these possibilities have to be, they have to connect with all the things we know. So we can't suddenly find things that just somehow don't fit at all with what we know. It has to be a part of it. So the historical record is part of the constraints on the possibilities. Yeah. So I have these possibilities. And this possibility, say number one possibility, that's maybe 1 in 1,000. And this possibility is maybe 1 in 10, and so on. So maybe there's 100 or 1,000 different possibilities of what I might see and the arrangement it might be in. So I have this distribution of all the possibilities. It's a probability distribution, some possibilities being more likely than others. Okay, now think of that, the way this works is that every one of those probabilities in the probability distribution, let's say if this probability is, I don't know, let's just give it units or something. If this probability is 10 units high, okay, then think of, I've got a box over here that I'm going to take a random draw from, like in a raffle. Think of that 10 unit high probability as being 10 pieces of paper in my box with that possibility's name on it, okay? And this one now is 100 units high because it's a lot more probable. This one's only 2 units high because it's not so probable. And every one of those has, that's how many pieces of paper are in my raffle box. Okay, so that's what I mean by taking a random draw from the probability distribution of the possibilities. I'm going to reach into my raffle box over here where I have all of those pieces of paper, and I'm going to randomly pull one out. Of course, there's more pieces of paper in there for that one that was 100 units high because I had 100 pieces of paper for that one in that box. The one that was only 2 units high probability, I don't have 2 pieces of paper in that box. So you mix them all up randomly, you reach in, you pull out a thing, and that's what the scientist sees when he looks through his telescope. That's what he sees. That's where reality comes from. Now that image then is put in his data stream. Remember, it's a virtual universe with a virtual telescope and a virtual body avatar. See, all of that's just in the calculation, in the computer. Okay, what's really going on here is information's being fed to consciousness. So that scientist gets that information, that thing I drew out of that sample. Now it could have been just the one that was only 2 bars high, or it could have been the one that was more, it could have been any of those. It's a random draw out of that, but it's more likely that it's the ones that are more probable. So out comes that, that's what he sees. Now that reality is objective in this virtual reality. It's objective to this virtual reality. He's seen it, he's taken a picture of it. Okay, he does his research, he publishes his paper, and anybody else looks there, is going to see the same thing, because now that's in our reality. Okay, so that's how it works. You take a random draw from the possibilities. Okay, that's the nature of how this reality gets done. So the reality, it only comes into this reality because that scientist is a consciousness with a data stream. It becomes a part of this reality when his data stream includes that random draw. Now it's in this reality. Up until that point, it wasn't in this reality, it was just potential, just possible. Okay, now, so let's look at the tunneling. Tunneling is where the scientists will have a bunch of particles in a bottle. And the bottle is usually some kind of a constraint, like if they're charged particles, it may be some kind of very strong electric field that repulses them and keeps them in the bottle. But anyway, they make this bottle It's this energetic bottle such that the particles can't get out. The particles don't have enough energy to get out of the bottle. Classically, the particles should all stay in the bottle. What they find is that every once in a while, some of the particles in the bottle teleport, it would seem, outside the bottle. They get out. They're not supposed to. They don't have enough energy to get out. Well, why is that? That's because if you look at the probability of these particles, now there's a billion particles in here, maybe 100 billion. It doesn't take very big bunch of mass to make billions of particles, right? So we look at the probability. The probability of where every particle is a thing that goes from minus infinity to plus infinity if we're just on a line. It goes from way out here, it's almost 0, 0, 0, 0, 0. Get to the inside of the bottle, oh, it goes way up where the probability is, it goes way down, and then it goes all the way back out to 0 again. Well, this tail of the curve, you know, it's not zeroed outside the bottle, it's just very, very small. Eventually out to infinity it goes to 0, but it's what's called asymptotic, right, to the axis. So you've got a little bit of area under the curve, on the probability curve, it's out here in the tails. But that's maybe 1 in a million that it's going to be there. So it's like 1 in a million that if you measure this particle, you're going to find it outside the bottle. But that's the nature of the way it's done. It's done with this probability distribution. Probability distribution doesn't get to the side of the bottle and go from 0 up and down and down. It's not a square wave. They all have to be smooth. Curves, that's the nature of our reality. Our reality is smooth. See, it's not jerky, it's not jumpy. So what happens is, okay, 1 in a million that this particle is going to be outside the bottle under the tail. But there's billions of particles there. So what's the probability if I measure? I'm going to find a particle outside the jar. It's pretty high. 1 in a million, when I got billions of particles, I'm going to find thousands of particles outside. You see? And that's how they escape. That's the way it is. And all of our reality is done that way. Everything comes into this reality that's new. It gets a random draw from a probability distribution. That's how it gets here. So that would describe why tunneling works. That's the nature of the way reality works. Now, what about quantum entanglement? How is it that particles get entangled? And furthermore, with the Einstein, Podolsky, Rosen,
Yeah.
the thing that was more amazing about that is that if you had two particles entangled, so now these are entangled pair. Well, not yet. Thumbs are pointing in opposite directions. Now they're entangled pair, and that's because there's a spin, and the spin has angular momentum. Yeah. And does this really mean something spinning? No. You know what spin means. Spin's just a word we use because it acts like it has some kind of angular momentum, but we can't think of it as a physical particle spinning. That's just a metaphor. Yeah. Science uses a lot of metaphors these days because they realize that nothing really works if you try to be too more specific. So you have a spin up and a spin down. The reason you have that pair is now the angular momentum is 0 because the up cancels the down. Angular momentum is a vector. You have a vector in this direction, in that direction, they cancel each other out. Yeah. So the system had 0 before, conservation of momentum. It has to have 0 after. Okay? So that's why you have these. Now you separate these a long way away on the other opposite sides of the universe. So it would take light, 100 million years to go from one to the other. You flip one, the other one flips right away. Not 100 million years later when a signal gets to it, but right away. Well, that was thought to be impossible, that you were doing something faster than light speed and whatever. But quantum mechanics, when you chug out the math, it said that would happen. Well, the way you think of that is these are not two separate particles. That's just our viewpoint. It's one system. It's an entangled system, and it's just one thing. It's not two things. And you change this one, and that one changes. When you change this one, that automatically changes. And how does that work? It's an if-then statement. For you, those of you who are programmers, there's these logic statements in computer code that says, if this condition exists, then do that. It's just a simple logic statement. This thing that is one thing, this entangled pair, that entanglement sets up a logic statement that says if this spin changes, that spin has to change to the opposite. It's just that simple. So you don't need to have an effect that travels from here to there. Matter of fact, I don't know if many of you listened to the talk I gave in Atlanta about 3 months ago or so, but I talked there about action at a distance. See, this is action at a distance. We're flipping one and something else happens a long way. Action at a distance. Well, a lot of things are action at a distance. I'm standing here and there's nothing physical connecting me to those back there, but it's getting my voice, it's recording my picture, and it's all the way over there. How does that work? It's action at a distance. There's an electromagnetic field, comes off this little antenna, and it fills up the room. There's another antenna back there that gets that electromagnetic field, turns it back into electrical impulses, and turns it back into sound, right? Well, the only thing is there is no such thing as an electromagnetic field. An electromagnetic field is a creation of mathematics. It's not a physical thing. And people would say, oh, I can measure it here. Sure, you can measure the force. The electric force, I can measure it here. Or if I have a charge here, I can measure a magnetic field over here and here. Well, what that means is every point in space has a value relative to what this charge is or what this current is or something, you see? So it's just numbers in space. It's information. Sure, I can measure it, but I'm not measuring the field. I'm measuring force. There's nothing that measures a field. You measure the force, right? The effect of the field. There is no field. Well, you're just measuring the effect. And that's true of all the action at a distance. Gravity is the same way. Gravitational field. Well, you just, maybe 4 months ago, we first measured a gravitational wave. There are no gravitational waves. What they measured was a gravitational force. Suddenly the force of gravity changed a little bit and there was a blip in it. And they could relate that to something far away. So the theory is, because we dearly want to make this physical, is that something far away created this field that came over here and caused this blip, because that makes us feel better. That's not how it works. That's how the math works. You can write mathematics, but the mathematics is just describing the rule set. It's a rule set. The rule set says that if I have a charge here, then I'll be able to feel a magnetic force someplace, or if I have a charge here, an electric force, if I have a dipole here, I'll have a magnetic force, but if I have a charge here, there'll be some force that the electric field will create here. Well, the electric field doesn't create it. The rule set creates it. The rule set says this is the way it works. What we do is we understand the rule set in terms of mathematics, because that's the way the rule set's made in terms of mathematics, and then we begin to believe that it's our math that creates the force. Our math doesn't create the force. The field doesn't create the force. The rule set creates the force. You see? There is no field. Action at a distance doesn't happen. It's just the way the rule set is made. The rule set has this rule that says, if I flip this particle this way, that one's going to flip the other way. Just the rule set. I don't need this one to communicate to that. The rule set says this is the way it works. So that's how I would explain that to them. It's the nature of a virtual reality to work that way. When I was doing virtual realities, let's say I was looking at an electromagnetic field going out and hitting something, a target of some sort, and then bouncing back. Okay? And I'm modeling this. I'm modeling something that has to do with radar. Well, how do I model that? I model it that at time t, I send out my electromagnetic field. At time, a little time after that, the distance out and the distance back, right? Divided by the speed of light. That's how fast it goes out and comes back. Well, I wait for that much delay, and then I say, here's the pulse. That's how I model the radar system. I don't model, I don't model some process of something that runs out here and bounces and runs back. I model the interaction at the target, so I know how much reflects back, and I model the time that it takes to do that, and that's how I model it. I don't have to model the process in between. You see? This is a virtual reality. A person on YouTube came up with another example that's kind of interesting. The same idea, say, with a cell phone. Now we have cell phones, and they're very complex pieces of equipment, very complicated thing. If you look at all the science and engineering in a cell phone, it's a near miracle that, they exist, because it's a very complex thing. But you send a text message, and you send it to somebody that lives on the other side of the world. So what happens, you type in your text message and you say, go. And a little while later, somebody in Africa gets a text message, and they read it. Now, what we say is that the electromagnetic radiation from the antenna of your phone goes out to a cell tower that picks it up, that moves it to some other cell tower and some other cell tower till it gets to a place that talks to satellites. It sends it up to a satellite. The satellite sends it around to other satellites until it gets over the right area, and then it downloads that from that satellite to that guy's cell phone, and then the message gets there. It's got all of this process. Okay. Now, how does the larger conscious system model this? Well, your consciousness, you've got an intent, you put it in your cell phone, you say send. The system says, all right, that ought to be 4 seconds before it would get there. As long as all the rest of the stuff is logical, see, it all works. So the logic of the system says that this will all work. The logic of the cell phone, the logic of the satellites, the logic of the cell towers, it says this will work. And as long as all the logic is in place, the system says, okay, the logic is good. You push the button, it waits for the certain amount of time, it writes on the other cell phone. The system doesn't have to model the cell towers and all that in there. Doesn't have to be modeled. All that has to be modeled is wait the right amount of time, and that time is probabilistic. It may take a little longer, it may be a little shorter. So there's a probability distribution, see? And that probability distribution says, well, we might have done it in 3 seconds. Maybe it would take 10 minutes if it got hung up someplace or got in a place that then had to be down for maintenance for a little while. So here's our probability distribution. Anywhere from 1 second to 10 minutes. And the noise on the signal would be anywhere from this to that. And this is also part of the logic. So it looks at that and it goes in a random draw and says, okay, here's all the probabilities of all the times it'll take. I'll draw one. Oh, it's going to take 5.5 seconds. Okay? And here's a random draw from the thing about the noise and all the rest of it. What's that going to look like? Okay. And it puts that on that cell phone. It doesn't have to model all the stuff in between. It doesn't model cell towers. It doesn't model satellites. It doesn't model electromagnetic fields. It doesn't model any of that. All it has to do is take 2 random draws from 2 different probability distributions and write the answer at the right time with the right amount of noise on it. That's all it has to do, because the system is here to feed consciousness. You got a consciousness on this end that sends a cell message. You got a consciousness on that end that receives a cell message. Anything in between is irrelevant. You got to give that consciousness on that end the right answer according to the logic. So now let's say one of the cell tower that picks up your signal usually is down for some reason and you don't have a signal. Well, then that message won't show up over there because now the logic trail is broken. It won't work. What's the probability that it'll work? It's another random draw from another probability distribution. Okay, we got all these pieces, thousands of pieces in it. What's the probability they're all going to work? Well, it could be they won't work, could be they will work. What do we see? Take a random draw, oh, it worked, good. So we send the message over there, see? If you got the probability that it doesn't work, well, now somebody has to fix it. It doesn't work. Well, now they have to decide where the problem is, right? So the system didn't work. It has to model that problem because now it's said something, right? So it's got to go model that problem. And it has to find some link, some logic link, some component that isn't working. And that's another random draw. Well, it could then be these 6 products, pieces that isn't working. Like a random draw. Oh, that's the one that's not working. Okay. You see how our reality is done?
Yeah.
It's just done with random draws from probability distributions.
Yeah.
There is no action at a distance. There are no electromagnetic fields.
Right.
There is no gravitational fields. There's just forces, and the forces are defined by the rule set.
Yeah.
And some things in our rule set, just like if I were making a simulation, things just happen at the right time, because why would I somehow want to worry about a field and its progression through space in my simulation? I don't care about that. What I care about is the signal that comes back.
Yeah.
So I care about the interaction with the target. That tells me how much signal will come back. And I care about the time it takes to get there. That's all I care about. The rest of it is irrelevant to me. I don't model it. Well, why would anybody model it? You only model where the measurement's made, which is where it was sent, where it was received. Everything else is skipped. So you see the power and efficiency of a probabilistic simulation.
Yeah.
If you were doing a deterministic simulation, you'd have to model every wire, every chip, every atom in everything through the whole chain over and over and over again.
Right.
Anybody anywhere in the world sends a text message, you got to start over, and you got to go through every atom and everything. You got more calculations than 100 supercomputers could do in a year. You see? And there's no point. In a probabilistic simulation, you get this point and that point and a couple of random draws of what could go wrong in the middle, and you're done. So how long does it take in a computer simulation to make 6 or 7 or a dozen random draws? You know, insignificant, right? Trivial. Well, there's your answer. How long would it take to calculate what every atom and molecule is doing in this very complicated chain? Forever. See? That's why it's a probabilistic simulation. Not because I like probability, but because that makes sense. That makes it doable. And its only restrictions are, it has to, the things that are possible in this probability distribution are restricted by history. They're restricted by what's happened before, what's been in this reality before. That's the thing. It has to be consistent. We can't have any big glaring inconsistencies. You can't look into that piece of outer space and suddenly see things in there that aren't like anything in outer space anywhere else. Suddenly there's something else there. Everything in there, is green and white stripes and yellow and orange polka dots, and that's the way it all is. And you say, that doesn't make any sense. Why that? It's not like anything we've ever seen before. Well, you can't do that. It has to be consistent with all the other random draws that have ever been made. So as the system goes, of course, it's creating more and more constraints for itself. But that's all right. There's lots of room to expand into. There's lots of things we don't know and haven't seen. But as long as there's things that we've done and seen, then they're constrained by that history. The other constraint is it has to abide by the rule set. You're not going to be able to see anything that the rule set doesn't support. And the only reason you can get that result on that cell phone is that the rule set supports all of that chain, all of that logic chain. And the reason the rule set supports it is because people have invented it. They've created it. They have made computer chips. They have made antennas. They have built cell towers. They've done all that stuff, which creates the logic chain. If they hadn't have done that, logic wouldn't be able to do that. So because of our inventingness and cleverness, we can build a logic chain that allows us to send a text message in 5.5 seconds to somebody in Africa.
So what you're saying is that, for example, with the EPR, which I understand always works, right? It's 100%.
Yeah.
Is it not? So you're saying that the reason why the change in the spin of one instantaneously, so to speak, changes the spin of the other particle is merely the result of the setup of the experiment itself and the mathematics that underlies the proof.
It's the logic.
The logic.
Yeah. Mathematics is basically the logic of quantity. All mathematics is about quantity.
Yeah.
And it's how quantities relate to each other and things you can do to them and so on. So the logic of quantity says that if this happens, that'll happen. Mathematics says, it's a probability thing. Of course, quantum mechanics is probability based. But they know that if this flips, that'll flip. And it happens all the time. And yes, it's just an if-then statement. So it's part of the rule set. The rule set says, yes, this can happen. This is a part of the rules. It's not like there's something in our history or something in our rule set that says this can't happen. So it can. And
did Einstein call it that spooky effect because
spooky, yeah.
It didn't fit in with his classical mind?
It didn't fit in with, at that point, people had a hard time, they still have a hard time, getting their mind wrapped around virtual reality. don't they?
Yeah.
They have a
Oh,
really
sure.
hard time.
Yeah. Yeah.
And that was why.
Yeah.
You think about it. See, in those days, there was no concept of virtual reality.
Yeah.
See, we're really a step ahead here. We know about virtual reality.
Yeah.
We play virtual reality games. We know that you can compute other worlds, and those other
Yeah.
worlds are full of detail and all sorts of things.
Right.
They didn't know that then. If you just said, "Oh, it's a virtual reality," they just said, "A what?" Because that was not part of their concept, so
Yeah.
they couldn't go there.
Yeah.
But in Einstein's mind at the time, it just didn't make sense.
Right.
It didn't make any physical sense.
Yeah.
Well, it doesn't, because it's not a physical process.
And in fact, he
Yeah.
pointed that out as a way of demonstrating to the rest of the scientific community how ridiculous this quantum physics stuff was.
Yes,
So, look, if you believe this,
Yeah.
then you have to believe that.
right,
Yeah.
And it's obviously that's absurd, so therefore quantum
Right.
mechanics is incomplete.
right.
Which of course, later on, 50 years later, all the experiments have been done to show that Einstein at every step of the way was wrong.
Yeah.
On that issue, he
On
was
that
he
issue.
was wrong.
Yeah.
What was spooky to him was the spin setting exactly at the same time, which in your model, it shows that the spins are set in the time, the delta t above this one. And the spooky action is only spooky because it looks like they're immediately going spin up, spin down, but really there's a beat of time, a beat delta t, that decision is spin up, spin down is made. We don't see it because it's too fast.
Well, if you look
That's
at
you, right?
if you look at the code, and any of you have written code, you know it's a series of statements.
Okay, so one statement.
Okay, it's a series of statements. Now you go through all the statements, and then time increments of delta t, you go through all the statements again. Okay, so now this code is written such that here you say, okay, I'm going to flip a state. I'm in this delta t, I'm going through a thing, and all right, a state gets flipped. Now, if the two lines underneath that code say, well, if that one gets flipped, then the other one does, well, then two lines in the code is all inside the same delta t. This one would get flipped.
So it
Now,
doesn't happen at delta t,
if
it
the-
happens the same.
No, yes, in between our delta t's.
Well, if you want to say between them, I know what you're saying. Within
Beat.
the delta t,
Which is-
it happens. Now, if it were possible, but it'd be very bad coding, that if-then statement was written backwards. So you went down through the then statement, then you got to the if statement, and then you got the flag set, and then you had to go all the way back around again, change the delta t before you got back to that. It's possible that the code could be that poorly written, but I doubt it. I doubt it. So I would suspect it all happens within the same delta t, even though it's possible they could be one delta t separated. It could be that, but that's just a matter of how good a coder is the larger consciousness system. I expect it's pretty efficient. So, Yeah.
Like the, okay.
Talking stick.
Right. Okay, just want to, do you think that Schrodinger and maybe Heisenberg, did they understand this?
I think what they understood was that they didn't understand it.
Okay.
I think they were perfectly clear in their mind that they had no clue what was going on, that it had something to do with consciousness. It wasn't just physical, that the idea of materialism wasn't right, didn't work, and that there was just no physical explanation for it. And they were willing to leave it like that. We just don't know.
Yeah.
Well, that lasted for a couple of decades. And people don't like that I don't know
No, right.
stage.
Sure.
Makes them sound like they're not competent.
Right.
Well, how's that work? I don't know. Well, anybody could say I don't know. You could ask anyone, and they could give you that answer. So it doesn't make them feel good. So pretty soon they started saying things like, well, nobody will ever know.
Yeah.
We can't know. That's impossible to know.
Yeah.
There's no way that you can get from here to there. It's one of those mysteries that'll never be solved. Well, what that does is takes you off the hook. If it's impossible, then people will stop nagging you to give them the answer, right?
Yeah.
So that gets you off the hook from having to answer the question because it's just impossible.
Yeah.
And you have people like Richard Feynman, who was one of the top quantum mechanics theorists, very smart guy,
Yeah.
and he makes statements of the sort of, nobody will ever know,
Yeah.
this how this double slit is, or why it works that way.
Yeah.
It's just impossible.
He said, just do the calculations.
Yeah, and he told his students, just do the calculations. Don't ask why it works
They
this
still
way.
tell students that.
Yes,
I have little kids doing college physics now, they still tell them.
sure they do. Well, they don't have anything else to tell them, you
Yeah,
see?
yeah.
It's just do the math.
Let's do it, it works.
Right, because there is no explanation.
Yeah.
But in the beginning, it was like a new world. Wow, this is so exciting.
Yeah.
We finally uncovered a major thing here that is going to change our physics, our whole
Yeah.
concept of reality dramatically.
Yeah.
Not, it didn't. Because what happened was nobody knew how to get the next step.
Yeah.
It's like, okay, we got this big question here, and let's just go on. You know, let's just go on, because there wasn't any way to do it. Now Einstein he wanted to do this a big toe, right? Or not a big toe. He wanted to do a toe. It was a little toe,
yeah.
but he wanted to unify his relativity and quantum mechanics and had it all pulled together.
Yeah.
And he was one of the smartest, very inventive guy. He came up with a lot of new stuff in a very short period of time. So he was a smart man who didn't mind thinking out of the box.
Yeah.
After Podolsky, Rosen, and
Einstein.
yeah. After they basically, were handed the verdict that they were wrong, not only wrong, but very wrong. It was shown that they were wrong. He kind of said, well, okay, then let's come up with a theory of how all this could work.
Yeah.
Well, 20-some years later, empty-handed.
Yeah.
Okay, now how many other scientists were going to dedicate their career to
What he couldn't.
what he couldn't do?
Yeah.
See, not a whole lot of them, because he was more inventive out of the box than many. He did a lot of things, so that kind of put the,
Yeah.
the nobody really went down that route, because if you're in academia and you work for 20-some years and you don't publish a single paper,
Yeah.
you're not doing very well.
Yeah.
You're not going to get tenure.
Yeah.
You're not going to have a career. You're
Yeah.
nobody.
Yeah.
Now, if you're Albert Einstein, you can do that. You've already paid your dues. You've already written 4 amazing papers, and from photoelectric effect to all kinds of other things.
Yeah.
You've gotten, Nobel Prize.
Yeah.
If you want to spend 23 years and produce nothing, you can do it.
Yeah.
Nobody's going to say, we're going to take your tenure away, or, you're fired or something because you didn't get the answer.
Yeah.
Well, that's not true of anybody else.
Yeah.
You see, nobody else wanted to get in that path and end up empty-handed
Yeah.
and basically lose their career
Yeah.
on it. So it wasn't a well-traveled path, even though it was, look, we discovered something really big and new.
Yeah.
And you think that people would pick at that until they figured it out. But instead, they kind of looked the other way,
Mm-hmm.
decided it was impossible, therefore there's no point working on it anymore,
Mm-hmm.
and kind of left it alone. And then eventually started to even deny that the problem was there in the first place.
Mm-hmm. Mm-hmm.
It's, well, there's some physical explanation, but we just don't know what it is.
Yeah.
Oh, it's the thing that when you detect that particle, you somehow have to interact with energy to that particle to detect it. Okay, you're detecting the particle going through the slit. There's no way, it's impossible to detect that particle without somehow interfering with it, and that interference is what causes the problem. Oh, it's physical. Well, of course, that turned out it wasn't the case.
Mm-hmm.
Then experiments were done that said, no, not it. So still, probably half the physicists in the world believe that it's affecting that particle with the measurement, even though for decades, experiments have said that's not the case.
Mm-hmm.
There have been touchless experiments where you can measure it without ever touching the particle with anything, and it still works just the same.
Yeah.
So anyhow, that's not been something that the physicists have spent a lot of time worrying about. They haven't spent a lot of time trying to understand how consciousness fits into it. But yes, Schrodinger, Planck, Heisenberg, Bohr, all of them had the idea there was definitely something bigger going on here.
Yeah.
It definitely was not material. It definitely was connected with consciousness because of the way the observer seemed to have effect on
Right.
what was going on, but they had no clue as to where to go with it. And the status hasn't changed in almost 100 years. We're still at that same point, except now we've got all these other things, like you say, like tunneling and other things. That's
Yeah.
just more of that weird science that nobody will understand.
Are there rules of physics that aren't discovered yet?
Oh, sure. There's lots of physics that's not discovered yet. So how could it not, if it's maybe one of those, right?
Tom, could I just one little thing finally that would cap this?
Okay.
Can you just say very briefly what did Bell's theorem do about this? Was Bell's theorem an answer to this thing of non-locality?
No, Bell's theorem just said that non-locality existed, that you had non-locality, and that he had the logic to show that that's the way it had to be. In other words, we knew we had non-locality from experiments, but we didn't really have a good theory to explain why it had to be that way. And Bell came up and he said, well, you know, if there is non-locality, then we're going to get these kinds of fractions of things come out of this experiment. And sure enough, they did. So he really proved that non-locality was a fact. I shouldn't say he proved it. He corroborated it. He added some evidence to the fact that non-locality was a real thing.
Thank you so much. Thank you.
So shifting subjects a little bit, you've talked about this virtual reality being like a learning lab.
Yes.
And we're in kindergarten, things like that. And so that kind of implies that there's a graduation at some point. And I'm wondering if you've had any speculations on or thoughts on what that might be.
Sure. That's a good question. That's a very interesting and common question. When do I get out of here? Right?
And under what circumstances?
Yeah, and what circumstances? How do I get out of here?
What's next? Yeah.
And I have any number of people who feel like this reality that they're in has got to be the pits of all reality. It's got to be the worst possible place. You know, it's all this greed and misery and pain, and you know, they have a lot of fear, so their life isn't going very well. And they just think, of course, instead of blaming themselves, oh, it's my fear, they say, oh, this reality sucks. It's just awful. And I can't wait till I get out of here. I'm never coming back. Whether I graduate or not, I'm not coming back. Do I have free will whether or not I come back here? And I say, sure. And they say, good, I'm not coming back. So I get that a lot. And I also hear some people say, well, I know a whole lot, you know, I'm enlightened and I'm not coming back here anymore. It's my last trip. I'm out of here because I've done it all and I'm graduating. Well, all of those opinions are kind of bogus. None of those really hold up. The way it works is, if you are growing here and you're growing up and you're learning, you become very less self-centered and a little very more other-centered. Okay? So let's say you've learned a whole lot, then one would expect you to be very other-centered. Now, when somebody says, I'm not coming back to this hellhole, does that sound like they're other-centered, or are they primarily kind of focused on themselves, you see? When somebody says, I'm graduating, I'm not going to come back here anymore, well, there's a lot of need here. There's a lot of good to do here. There's a lot of people need help here. There's a lot of encouragement, a lot of teaching needs to go on here. Yes, this is kindergarten, and there's a want for good teachers. So if you learn enough that you feel like you're just not learning that much here, then you ought to be teaching. You know, that's what you do. And people do that anyway. When you're at the beginning, and this will answer one of the questions we had, like where do you put your focus? When you're at the beginning, you're mainly working on your fear. You're working on your ego and your beliefs. And that's really your job, because that's the first step. And as you succeed in that, then you start helping other people, because other people are struggling and you recognize that struggle. I've been there. I've been in that struggle. I know that. And you can help them out. And even if you don't do anything to help people out other than just be kind, just give them a smile. Be the little old lady on the corner that gives all the little kids cookies, you know, when they come by, because she just thinks it's fun and she likes kids and she's trying to be nice. You see, you're somebody who's giving to the system. All of that helps. All of that helps pull everybody else up. So as you grow up, you start to be helpful. And then you grow up more, and now you can be more helpful. And you grow up more, and you're even more helpful. And doesn't make any sense that you finally get to the top and you've grown all this and damn, I'm out of here. You know, I don't want to help anybody anymore. I'm out of here. You know, this place is not for me. You see, that's not the way it works. Now, you may not end up in this reality frame. You may help someplace else, but you're not done. You're never done. There's always something to do. There's always somebody to help. And basically, there's always some growing to do on your own. Because the way entropy works, if you don't keep putting energy into it, if you don't keep working at it, it dissolves on you. It goes away. Entropy just naturally, stuff decays. Entropy grows. That's the second law of thermodynamics. If you just let things alone, they start to dissolve. They dissipate. You know, it's just like if you never do any maintenance on your house runs down. Pretty soon the roof leaks. When the roof leaks, it ruins the floors. It ruins the, the sheetrock. It ruins things. Everything starts to deteriorate. Everything has to be kept up with maintenance. So this idea that I'm done, what that means, if you really feel that way, and you say, oh no, I don't want to go back, no more incarnations for me, I'm done, I'm just going to sit here on this cloud and play my harp, and I'm not going to do anything, I'm not going anywhere. What you start doing is de-evolving. You start coming apart because entropy just grows if you're not constantly putting energy into reducing it, you see? So you don't want to be done. You need to be always engaged, growing, helping, teaching, somehow engaged. Just to sit around and do nothing because you feel like you're done means that, well, it won't take very long before you're not done. It won't take very long before you've de-evolved to the point that you realize, you've got problems and you've regressed and you have to get back in the game.
Yeah, so that's that really, I mean, I understand all that. That's not really the question I was asking.
Okay.
So the question was more like, not if I, this ego, thinks I'm done, but rather in the
system?
At the IUOC level, let's say, individual unit of consciousness, that unit has grown as much as it can in this VR.
I don't think you would get
Maybe you don't have an answer
I don't think you'd get an individual unit of consciousness that wouldn't be able to grow more. I think there's always, see, if you need, let's say you don't have enough bits for all the new information, bits are free. You get more bits. So I don't see any reason why your IOUC wouldn't continue to grow, continue to serve, continue to help. So I don't see that. Now let's look at the whole system though. System-wide. Does a system ever get to where it's at its capacity? Okay, because it is not an infinite system. It's a finite system because it's a real system. So it has a capacity. Could it ever get to its capacity? Well, possibly. And we could guess maybe some things it might do. If it got to its capacity, what do you do when your computer gets full? You look through it and say, I don't really need this stuff. And you delete all your your less valuable bits, right? And then you've got more room. So you just keep making it more and more condensed, I guess, as far as your information goes. So it could do that. But I don't really see that happening because I've never had any sense of limitations on capacity. I've always had the sense that the capacity is just so enormous that limitations isn't even something that we think about. And then who knows, like in the books I do some, some speculation. You can speculate, right? And maybe this whole system is just a piece of another system. Maybe it uploads everything to some bigger thing, hits the reset button and starts over, I mean, it's hard to say. We can speculate all sorts of things.
I mean, I think I was asking for speculation.
Yeah, but it's more speculation than anything else.
That's in the book.
Yeah, that's in the book. Yeah, I even get silly in there. I say that it may be the cell, this whole thing may be one cell in a big Aomosaurus. Remember that?
Right.
So and I got silly on purpose because I wanted people to realize it's just speculation. Don't take any of it seriously. It's just things that you can make up. But we don't know, and that's outside of our ability to understand. Yeah, so we don't know really about system questions. You have to be outside the system to do that, and we're not. We're consciousness inside a system, so we just don't know.
Yes, actually, so my question ties back to what we were talking about before regarding the science of uncertainty principle and the probability distribution. And I want to go back to the example that you were talking about with the two different observers at different parts of the world sending a text message, and there is this whole container of probability distribution between them. So does this probability distribution and the science of uncertainty principle, does it exist outside of the observers? And if so, would that imply some level of objective reality?
Yes, the rule set, I think is really what you mean. The rule set is outside of the observers. The rule set is what defines this virtual reality. A virtual reality has to be defined by a rule set. Okay, and that's, our virtual reality is evolving according to that rule set. And that rule set is fundamental, and it's there. And everything that happens in this virtual reality has to be in line with that rule set.
But what
Okay.
about, I remember you mentioned once probabilities just doing their thing in the background, like probability distributions change, going up and down in the background. Could that happen without any kind of an observer?
Well, you have to look at, there's kind of two kinds of observers. Actually, there's several more, but as far as observers being us, people like you and I, right? We can modify those probability distributions. Our intent can make something more likely or less likely. That's one of our talents, modifying future probability distributions, so that when that random draw is made, it's more likely to come out this way than that way. But no guarantee, because that random draw could pick something out under the tail or whatever else. Yes, we do that. Okay, and if we don't do that, they just stay as they are. What's probable? Okay,
How
we
is
don't
that
modify them.
determined?
Now, there is another source of probability that can, or another source that can change them. The larger system itself can change things. So if the larger consciousness system says, you know, it would really be good for you to have this experience, okay, then they can maybe engineer that experience, nudge it, make it more probable to happen. They can't do it outside of the rule set or outside of history constraints. They still got to stay inside of that. Otherwise, we get discontinuities in our reality. So within those constraints, it can change the probabilities just to give you the lesson you need. So you get kind of a customized experience. That's what happens to a lot of people who have spontaneous paranormal experiences, whether it's a spontaneous out of body, or they, you know, after 2 weeks after their mother dies, the phone rings and they pick it up and their mother says, hello, I just wanted you to know I'm fine and everything's okay here. And then the line goes dead and they're going, did I just imagine that? You know, what was that? And occasionally they get it recorded on a phone that records. So those kinds of one-off experiences are just given to people to help them deal with situations. It's a learning point, something they need to see, something they need learn to they need to experience to learn. So that's another thing that can change the probabilities. But other of those, entities like us, physical or non-physical, can modify probabilities, and the system can modify probabilities. The rest of it, it just gets calculated, and according to what we do, changes them. I mean, the probabilities are changing all the time. If we all, you know, if let's say there's a big fad going on and everybody wants to buy a Beanie Baby, well, the probability that any particular person is going to go out and buy a Beanie Baby and they're in our culture just go way up.
Even
Because
if
now
you're
people
not
are standing
observing
in
it.
line. Yes, even
Even if I myself, I'm not observing that particular phenomenon,
right.
would that still happen?
Yes,
And
that
that-
still happens because other people are involved in it, even if you're not. There's consciousness there involved in it. So it's not just that you, the observer, create everybody's reality.
Right.
You, the observer, create your reality. Everybody else creates their own reality, but there are constraints that make those two match up mostly.
Got it.
See, so you don't have to be involved in it before it works for other people.
So I guess, like, and I've asked you this question before. So what about, like, in terms of like a illness or a diagnosis, for example? Let's say you might be diagnosed with something or not. Let's say you don't make that measurement. You don't do that pathology, and does that thing stay in the probability distribution in the area of the
Sure. So let's
So,
say,
so
let's
wouldn't it
say,
be a better idea to not ever go to a doctor, let's say, and get diagnosed?
No, it's not better necessarily to avoid all the doctors, but it's like this.
Right.
If in the beginning, early on, you have a very positive attitude, and your attitude, you don't have much fear, you don't have much beliefs, you're a real positive kind of person, well, your probability of getting any kind of illness is less because you're not feeding negative things with negativity. So it's much less. So in that way, you're affecting the probability. But, oh no, you get this lump and it's someplace, okay? And that worries you. The next thing that you should do is have to have a real serious talk with yourself about your level of fear concerning this. If you have a high level of fear concerning this, you need to go see your doc, have him look at it, decide what it is, do the biopsy if he wants, or he can feel it. And if it's a hard little lump, that's not good. If it's a squishy lump, that's much better. And then you can do that. And the reason is that if you don't, if you say, oh, I'm not going to a doctor, I'm going to just work on this myself and have my friends work on it, but you're fearful, it's not going to work because you're fearful. You're going to be terrified that you've made the wrong decision. Should I have gone to see that doctor? What kind of trouble am I getting myself in that I made this decision not to see the doctor? And all of that fear will start putting energy into that being a problem, you see? Now let's say you're not a fearful person. You have no fear. Life is good, you'll live, you'll die. As things happen, that's okay. You first spend your life being positive, getting rid of your fear so you don't have any of the issues in the first place. Second, you get an issue, try to work on it, get other people to work on it too. Find a healing circle someplace, get them to see it. And if it disappears, good. You don't have to go see the doctor. You're good to go. If it doesn't, next question is, how fearful am I? If I don't see a doctor, is that just going to stoke my fear? And if it is, go see a doctor. If it's not, you might spend a little more time working on it. But eventually, if you end up getting a little more fearful and concerned about it, go see the doctor, you see? Because the doctor can diagnose it, and if it's still a little lump, it can just take it out, and you're fine. If you wait too long and it metastasizes and spreads all over, then you're not so fine. So you see, going early is important. So that's kind of the way to do that.
Yeah.
It depends on you, depends on how you feel, it depends on how frightened you are, all those things. You just do it differently depending on the situation.
Thank you, Tom.
You're welcome.
Yes. I know. This question tortures me for months. I think in the first book of yours, you're talking about an experiment that moved everything for you from intellectual level to the being level. Experiment you conducted with Bob Monroe and somebody else in 2 different rooms.
Right.
And you were going to the same place, and
Yes.
something was, maybe you can tell about it better than I am. So my question is, why don't you repeat this experiment to market your theory? Can you imagine how much attention that would bring?
Yes, I can imagine how much attention that would bring, and most of it would be negative. That's the problem. It would bring lots of negative attention, and I think by the time all the pluses and minuses were added up, it would probably be more a minus than plus. I don't think demonstrations are of any value. You can demonstrate things, but it's just not of any value because unless somebody's there with you, unless they know you, if they're part of your demonstration, then you may change them. If they just read about it or see it on the internet, no credibility whatsoever. Disney makes pink elephants fly. So you can make almost anything happen on YouTube. So people just don't, it's easy to just blow it off. It's not important. But the people...
It could help to validate an experience. Oh, I'm sorry. It could help to validate an experience as well for many others.
It would help It would help validate an experience for, I think, a few compared to the many who it would not. And also, probably even more than those few, would be ones that would be energized to holler bunk, fraud, they made it up, conspiracy, you know, all that sort of thing. So you'd get a whole lot more of that. So you'd get a little bump up on the positive side and a real big pull down on the negative side. So it's not really worth it. It's more of an individual thing. You won't really believe it until you do it. See, that's the problem. It's hard to tell anybody, you don't want to tell anybody anything that puts them in the position of having to believe you or not believe you. That's not a good place to put them. That's not really good for them, you see. So if I tell somebody, you know, people want me to tell stories. Tell us about your adventures in the outer body, right? The place you've gone, people you've seen, all the things that happened and whatever. And I don't do that because you'd either have to believe it or disbelieve it. And what's the point in that? How is that going to help you? It will just not help you at all. It will bring up at least as many doubts as it will confirmation. And it will make you have a higher tendency to want to have my experience because you'll think, oh, that's the way it is there. Oh, Bob Monroe went to a park. Oh, I see, there's parks there. Well, I want to go to that park. You see, that's Bob Monroe's park. That park was a metaphor. That park doesn't exist anywhere. It's a metaphor. It's a metaphor for a serene, quiet place where you can kind of be by yourself and think and that sort of thing. One guy's park is somebody else's beach, is somebody else's mountaintop, is somebody else's rowboat in a lake. You see? So that's Bob Monroe's metaphor. But people read his book and they want to go to his park. They want to have his experience. He says, I rolled out of body. And people try to roll out of body. And it doesn't work. That worked for Bob. That was a metaphor that worked for him. But if it's not your metaphor, it's not your tool. You see? So if you tell people things that they can't vet, or they can't analyze, or they can't tell how good the information is based on their own experience, you haven't done them any good. Belief or disbelief is not helpful to them. Doesn't take them anywhere at all new. And if you give them some idea that they think now this is the way the reality is, you've actually done them harm because now they'll go get something, they'll find something, they'll have an experience and they'll say, oh, that's not right. That couldn't be right. That's not the way Tom Campbell did it. That's not the way Bob Monroe did it. So that couldn't be right. It's going to be this other way. I didn't see these things, you see, like they did. So I must be not doing it. Well, now they quit or they feel failed when they were doing it perfectly well. See? So you've just made it harder for them. So I generally think that demonstrations are not good. They do more harm than good. You know, the group that is the loudest is usually the group that's negative. The group that would likely learn, they tend to be quiet and they take their information and they integrate it, and that's nice. But the group that makes all the noise and all the splash and leaves 10,000 comments somewhere on the internet, that's the negative group, not the positive group. And you energize that group if you say anything at all that is outside of their reality. So it's just good marketing not to energize that group, because now you lose ground, because the ground you'd like to gain is in that great mass of people who are on the fence, who've thought about it, but they haven't really thought much about it. And you can push them a little bit and they'll say, yeah, it's all nonsense. Or you can push them a little bit and they can say, oh, I think maybe there's something to that. Well, if you have a lot of negative stuff going on, there's a lot of those fence sitters that'll fall over to that negative side that will now become closed-minded because they hear closed-minded stuff about it. So that's not good. So I don't think the demonstrations are good. I get that a fair amount in email. You know, you could just do a demonstration, you know, do this something, everybody would have to believe you. Nobody would have to believe me. Everybody would think that it was a trick, unless the people who were there. The people who were involved in it, yes, it might change them, you know, because they'd see it. They'd know that they couldn't excuse it some other way, that it wasn't a trick, because they were right there with you when you did it. But everybody else, yeah, it could change anybody's mind.
Maybe someday by BBC, then they believe.
Yeah, well, I think they have to experience it themselves, but until they're ready and are open, that's unlikely. But on the other hand, as more and more people understand, as more and more people get the big picture, we all communicate to each other with our consciousness to conscious. More and more people will kind of be nudged in that direction. And you get a critical mass going, and then you're in the same league as Beanie Babies. You know, Beanie Babies get to be a big fad because everybody was picking it up from everybody else's mind. There's tens of thousands of people standing in line to get a Beanie Baby because it's the most important thing in the world, and that makes another 10,000 want to go out and do it too, because we're all connected, consciousness to consciousness. So these fads kind of run through the population. You can see them moving. They start on this coast, you can see them moving right through. Well, they jump over to the other coast, and then they come both together and meet in the middle. As you can just see how it progresses through the population. That's the consciousness to consciousness. Somebody gets excited, other people around them get excited. So we can get to this critical mass where there's enough of us that see the big picture. We'll start pulling all those fence fitters to our side. All of a sudden, people who never thought about it before will say, that's interesting. I want to find out more about this. And as the gentleman said there, he said, a couple of months ago, I never would have guessed I'd be in a place like this. You see? But you pick things up, and people have an inclination maybe to get involved or to find out or to read, and then they come on board. And so that hopefully we will get a critical mass of people, and then the rest of them will all kind of just fall into it. They'll be kind of drug along with us. Yeah, it's happening already. There's a lot more people getting interested. Yes, I think it.
So you have to be ready for this kind of information, and once you're ready, you find the teacher. It's green.
Yeah, okay, good. That's true. We have
so
to be ready.
So you can freak a lot of people out. You know,
Exactly.
Somebody who is a religious fanatic, let's say in Judaism or Christianity, and you tell them, listen, your whole concept is false. That's not going to be a positive thing for them. It's just
right.
There's going to be a lot of resistance.
Right, you have to be ready, and that's what we've been doing for the last 3 or 4 million years. We've been evolving to the point that we're ready.
Right.
And we're
so
trying
there's more people finding you.
Yeah, we're trying
without
to
really looking,
yeah.
just it comes. It's like when I found you, I didn't have an intention of I need to find Tom Campbell. It's just I was ready for information. Boom, and it was there.
Yeah,
but maybe 10 years ago, if I found something like this, or 15 years ago, I would have turned it off or been very discouraged or thought this is
Sure.
crazy. And it's impossible. How is this?
Yeah, I think this is great. There have been little cells of enlightenment. I use the word very generally, meaning people who see big pictures. There's been cells of enlightenment in the world for thousands of years. Thousands of years, and not just one place, but all over. Thousands of years, but they've always stayed in the margins. And they always stayed in the margins and were local because there was no way for them to communicate to a larger audience.
Or we killed them.
Or people who disagreed with them, yeah.
And then we kill them, right?
Yeah, people who disagreed with them killed them, yes.
Yeah,
That happens sometimes too. But they've always been there, but they've never gone mainstream because they've always been isolated geographically and communication-wise. So they grow into a little group, and in the few cases where they did spread wide, the spreading process also diluted the understanding to the point that by the time it got reduced to the lowest common denominator, it didn't have anything to do anymore with what the original idea was. So those have been the problems. Today, we have the technology to overcome those problems. So for the first time in the history of the human race, we have the capacity to, all of us, head down this path, pull those that are on the other side with us as we go. It's never been possible before. So yeah, this is something new for humans. And maybe we'll do it now. Maybe it'll be in a century from now, or maybe it'll only be 10 years from now. Who knows? But at least now it's possible. Before it wasn't. It wasn't even possible. or the probability was so low that it
we
just never got
evolved.
drawn out of that
Right.
distribution.
On the consciousness level, we evolved because now no one killed you so far. So,
That's right.
you know,
right.
it would have not been possible thousands of years ago. 2,000
right.
of years ago, there wasn't a possibility.
Yeah,
You know,
that's-
so
that's
we
true.
evolved. But I don't
Yeah.
know if.
Yeah, there
if
was a
you were-
time, particularly I know in Western society, that if you stood up and had ideas that were really against the prevailing wisdom, you know, you were a heretic or a witch or something worse, and it may be the end of you.
Well, there's still places in this world that are just like that.
Yes,
And
but they're not all like that, you see.
They're smaller.
We're moving, we're making progress. We're going from kindergarten up to first grade. We are making progress. So it's very hopeful.
Well, originally I was going to ask you like a science question, but since we're in this angle, I guess I'd like to say thanks, because in one of your first interviews, you had this throwaway comment where you said, "Why don't you try a Ouija board?" And I had no idea what that was going to open up, and it turned out to open up a whole lot for me and a bunch of my friends, actually, because we started to get, as a platform, it turned out to be a very like efficacious one to getting information. And it wasn't always very clear. Like after a while, I started thinking like, this is some kind of chat bot. Like it's just kind of saying whatever we throw at it, and it's just kind of, but the interesting thing about it in terms of a psi effect was not what it was saying. The fact that the coin was moving was what I took as being the most interesting part of the psi effect. Not so much the information, but the psychokinetic effect right there. So
Yeah.
I want to say thanks for that, because I never thought to play with a Ouija board.
Well, you know, Seth Speaks was written by Jane Roberts.
Oh, yeah.
And Jane Roberts got the Seth Speaks through a Ouija board.
Oh, yeah. So since we're on the topic, I was thinking, I've noticed that a bunch of my friends, a bunch of my close friends have been able to sort of provoke certain really interesting small-scale paranormal experiences for themselves and for other people who are open to it at the time. And it happens kind of on the fly and surprisingly casually. And you can see the science certainty effect happening in terms of if someone's really, really biased, nothing will happen. And if there's too many people around, nothing will happen. So this idea of remoteness and liminality plays a very strong role in
Sure.
provoking paranormal effect. So what I was wondering is, for everyone here, do you have any suggestions for people who are curious about it? Maybe not so desperately curious to like sorcery, but if anyone's like really interested in provoking a minor paranormal
Yeah.
effect for themselves, do you have any
Sure,
suggestions?
there's three things. I would have said two that I recommend because they're both easy to do and they're both available to anybody, and anybody can get some success with them in a 6 months or so of effort. And they are remote viewing and healing, right? But there's another one that came across my mind. I got a little note about somebody doing psychokinetics, moving things. And I went up onto the web, and there's a whole bunch of websites that'll teach you how to do psychokinetic stuff. And what they do is they set things at a very delicate balance.
Okay.
You see, they'll set something up at a very, very delicate balance, and then they'll use their psychokinesis to knock it over this way or to pull it that way. You see, and from what I saw on the internet, of course you can see anything on the internet, right? You can see flying elephants on the internet. But from what I could see on the internet, that they were claiming this was a skill that anybody could learn. That they just started practicing, and it took them some months. But after a few months doing it, they were able to do it. And the more you do it, the easier it is to get better at it. So in their viewpoint, they had figured it out for themselves, had done it, had taught numbers of other people to do it. So I assumed that anybody could learn that. So maybe I ought to add that to my list of things that are easy to do. But you just go on the web and find out how that you can use your mind to move things, make things happen. Now they didn't, huh?
Is that bending the rule set?
Yeah, but it's only bending the rule set just a little bit. And that's what Elliot's saying.
Yeah.
If you bend it too much,
It won't work.
it won't work. If you get too many people looking at it, it won't work. But if it's like one guy on the on YouTube, one guy on YouTube along with 500,000 other people on YouTube, that's like a grain of sand. So that's not too much. So you can find it there, and evidently people can do this and practice, and in several months, you will be able to do these things. You use your mind to make things move. So that'd be a demonstration. And it, from what they said, it's easy.
Anybody that can do it, raise my hand.
Yeah, so that's another. But anyway, the remote viewing and the healing are very simple. You heal with your intent, remote view the same way. It's easy to find targets. It's easy to find people who have ailments and would like you to help if you could. I mean, all these things are very easy to do. It's better if you have no idea what it's about. So if you want to practice healing, tell somebody else, friend of yours, say, look, find 5 or 6 people that have ailments in your circle of friends or in your acquaintances or whatever, and then just give me the first letter of their name, or maybe the 2 letters, their initials. Just give me their initials. And they'll give you a set of maybe 5 or 6 initials, and then you will look at each one, try to diagnose them, and say, write down, what you saw that was wrong with them, and then try to heal them. And then after you've done that, you get your friend back and say, okay, here was, JK, and here's what I found. What did they have? So JK, the person, your friend, should know that, be able to tell you that, what the problem was that they had, and then you can find out later if they got any better, whether your healing worked. So you can do this, and then you can get some of your friends to give them so that they can practice it. See, it's good to do it in teams because each of you can get people the other person doesn't know. It helps that if you have no idea who JK is, because now you don't have any biases. If you know who it is, you start guessing. Your intellect gets in there and starts to put information into the data stream. So the less you know about it, the better. And the same with the remote viewing. The less you know about it, the better. You can randomly pick 2 coordinates and then put those coordinates into a program on the internet that you can Google. It'll show you where that is in the world, what you might see there. And with Google Maps, you might even be able to go down and actually see what it looks like, and then see if that's what you saw. So there's things you can do like that remote view, or you and a person can agree to remote view each other, what you were doing at a certain time, or where you were, or whatever, and just practice. At first, you won't be very good at it, but the more you work at it, the better you'll get. The less you get your intellect involved in it, the better you'll get. Work from the being level, not the intellect. So those things, to heal, to remote view, and from what I understand, to move things with your mind, psychokinesis, are all easy things to do that anybody can learn and probably get good at in 6 months. Well, 6 months isn't very long. Your first couple of months, you'll probably be awful at it. You probably think, I just can't do this. Well, if you think that, you won't be able to. Just keep trying. Be open-minded about it.
Well, this is unfortunately a fear and ego-based question. But lately, I have traveled a little bit. I have seen things here in the U.S., in England. I have seen a lot of the artificial intelligence being applied. Mm-hmm. So it's not my imagination, unfortunately. And also, I just went to a trades fair in Mexico where they had all these robotics, that I talked to the people there. And basically, robotics can be applied to almost everything now. I mean, they have become very cheap, very convenient. It's just a matter of time until they are applied almost in anything. Mm-hmm. So should we just ignore the whole thing or brace for impact?
Well, I think it's inevitable that we are, maybe even in the next 20 years or so, going to find consciousness in computers. Now, you don't program consciousness into a computer. You create an environment that consciousness can use as an avatar. Okay, so you create a set of conditions, and they have to be, you have to have free will choices. So it can't just be algorithmic. You can have AI that's just algorithmic, expert system. It's all if-then. You know, if this happens, then do that. And if these three things happen together, then do this. And it's just a lot of if-then logic statements that make the thing seem pretty intelligent. But it's really not intelligent at all. It's just following logic stream. Okay, that's an expert system, really. If it really does have free will choices, it can come up with something on its own. Then when that gets interesting enough or at a level where a consciousness would like to use that as an avatar, it'll be conscious. And that consciousness will start making those free will decisions. And you'll have a conscious computer. So the consciousness will come to it if it's an avatar that's available. Now, it won't be a human conscious. It won't be conscious like us. It'll be more like conscious to begin with, like the mouse or the bumblebee or something. You know, it's going to be a very small consciousness because it's going to have a very small set of free will choices that it's going to make. And those free will choices won't be terribly meaningful in the big picture. It'll be more like small talk or something. But this will grow, and it'll expand, and it'll get better. So I think it's not a bad thing at all. I think it's a good thing. I don't think you should brace for impact. I think you should prepare to applaud. I think it's a good idea. But, of course, that depends on whether or not we are grown up enough and intelligent enough to keep it working for us as a tool. Or we may eventually then decide that that's not nice. We should let it go free and let it evolve however it does in its own way. But it can only do what the rule set we give it allows it to do. Right? It can't go making decisions that aren't programmed in there to be made. So it's up to us. So it's another one of those things where you got a great technology that could be supremely useful. You know how Spock and Captain Kirk would say, computer, you know, how long will it be before we get to Alpha Centauri? You know, and the computer in a nice female voice would say, you know, 23.578 seconds. You know, this sort of thing. It'd be nice if you could talk to your computer like that. That's a whole lot better than this. You know, that's pretty low tech. So it would be good if we could get those kinds of things available. Lots of uses for lots of people. It would be, you know, I can just see, you know, lots and lots of uses. But anyway, we always have the potential to abuse it like we do anything else. And we have the potential to use it. I don't think we should fear that potential of abusing it unless we really see that that's inevitable. Then perhaps we should go the other direction. Maybe brace ourselves. But right now I think it's probably a long haul before we get there. 20 years, 30 years, long haul. I don't mean centuries, but sometime. We have a little bit of time to mature yet before we get to that point. And I think it's more or less inevitable. You know, it's like back in the 17th or 18th century, you might say that, you know, it was inevitable that we would find a way to get around other than horses. Sooner or later, you know, somebody would figure out, because the horses are so limited and you have to feed them and house them. So that would be a good guess. I think this is like that too. It's inevitable that it is coming. One way or another, it's coming. Whether or not we will be ready for it so that we are intelligent and grown up enough to deal with it, we'll see when we get there.
Yeah, the problem, Tom, is that the horses lost their jobs.
Yeah, the horses lost their jobs, right? Well, the horses need to be retooled into other things. You know, and it's like that with technology all over. Technology has been taking people's jobs away, but it also creates new jobs. Technology creates and takes away, but it creates on this end and gives over here on this end. That's like we're doing that in our economy. We used to be an industrial powerhouse. Made in the USA, it was a great thing. Well, hardly anything's made in the USA. Now look at the tag and it's always made in China. Well, China's a big industrial powerhouse, okay, because they do it cheaper than we do because they don't pay their people very much. It's a very low cost of living in China. But that's the way it is. That doesn't mean that you know, it's a problem for us. We just have to go from manufacturing to knowledge work. We got to retool. Now, some people are going to get caught in that transition. All you've ever done is turn a crank on a factory, and suddenly somebody tells you you need to be a programmer. That may be too hard to get over. Well, for people that get caught in that, we need to have a safety net there that keeps them from falling through the cracks. We need to help them. One, we need to re-educate. We need to make available all kinds of ways that they can upgrade their skills. But if some of them just can't or won't, we need to have some net, because it's just the way progress is. When you make progress, some people used to make a living making buggy whips, and they had a big buggy whip factory, and their family was well off because of it, and now nobody wants a buggy whip anymore, you see, but that's okay, that's progress. But we need a lot of programmers now, and we didn't have programmers then, so we've created a whole lot of new jobs. So it's like that. Somebody's got to do the design, somebody's got to do the creating, somebody's got to do that end of the work, and somebody's got to work in a factory to actually make the thing and build it and distribute it and that part of it. So it's like we progress. As we grow up as a culture, we move from agriculture, right, digging in the ground, to industry, working in factories, to knowledge work, using our minds primarily, creating, designing. It goes like that. And other people who were in agriculture, well, they pick up the manufacturing now. And as they move on into the knowledge work, somebody else, you know, picks up the agriculture, picks up the manufacturing, and the whole thing kind of works like that. And eventually, who picks up the manufacturing and agriculture? Those robots you're talking about. They're at the bottom. Good. Everybody else will be designers and creators and be doing a lot of things, and maybe that's so efficient, there will be a fair number of people who really don't have to do much of anything. Might be a really nice place, particularly if we're all caring and loving and we've learned our lessons, you see. Now we have robots, you know, doing all the heavy labor, and we just try to optimize our growth and growth for everybody else. So you can see, you can paint a picture of a beautiful world, right? And of course, if you go and watch the movies, you can paint a picture of a really awful dystopia where the machines take over the world and eliminate the people and that sort of thing. But we'd have to allow that. That can't happen without our permission or without our stupidity, whichever.
What about the surgeon and the garbage man?
The what?
The surgeon and the garbage
Yeah,
man.
right.
Are they going to still have a job?
Sure, they'll have a job. As long as you have avatars, then you'll need the surgeon. And as long as you have people, you're going to need a garbage man. He's probably more secure than the brain surgeon.
I think they're both as important.
So, yeah, that's the point. You see, in our society, we value one very highly. We value the other one hardly at all. But yet, in a better world, they'd both be valued as necessary. They're both absolutely necessary to us getting along, right? We can't get along without surgeons and the people who can do technical things. And we can't get along without somebody collecting the garbage. So it's not like one of them is a high-value job and the other is a low-value job. And each job has its benefits. The benefit of one is good health, strength, vigor. You don't sit in a desk all day, you know, getting fat, eating donuts. It's a different kind of world. So there's advantages and disadvantages with both. Why not have all the advantages and none of the disadvantages? You play the garbage truck because that's an advantage to you. You're the surgeon because that's an advantage to you. It doesn't have to be a disadvantage to anybody. That's the point. We value everything, not just high status stuff.
As we evolve our individual quality of consciousness, it improves the quality of consciousness of the larger consciousness system.
Right?
Does the improvement we make in our quality of consciousness affect the quality of consciousness in our past lives?
No.
Okay.
It doesn't affect the quality in the past life. Past life is done.
Okay.
Now what it does, it affects the whole. So you have, you know, your individual unit of consciousness is like your integration function. It takes all the lives And there's some synergy in looking at them all together. You can see trends, you can see lapses, you can see things when you look at the whole package that you couldn't see if you just looked at any one. So it looks at all of them, and it changes itself based on what it learns. So you're going to have an experience package, you're working on that, you're uploading lots of experience, you're learning things, and your whole system will be hopefully better off for that information. And then next time, it'll be a different system. It changes all the time. So it learns from you, but it doesn't really, it's not that it changes the past lives, but it changes the whole.
I didn't know if the way the system worked, everything was simultaneous, since time doesn't really exist.
No.
Okay, so it is linear?
No, time is fundamental. You can't have evolution without time. You can't make a choice without time. There's no free will without time because there's no choice. The choice is, it was like this, I choose that, now it's like that. Choice makes changes. Without time, there's no change. So if you don't have time, you can't have free will, you can't have consciousness, you can't have anything. You basically have nothing without time. Time is fundamental. So because you have consciousness, because we have free will, time has to be a component of that. Otherwise, there's no change. There's no growth. There's no evolution without time. So time is a very fundamental thing. And time is linear, ticks away, keeps going like that. Now, it's not all uniform everywhere. Every virtual reality has its own clock. See, in this virtual reality, we have our delta t, that's our clock in our simulation, and that's our time here. But some other virtual reality doesn't have to have that same time. It can have whatever time suits it. And you get virtual realities like the dream reality, and they don't have a lot of sequential things that have to happen. You can kind of jump all over the place there because their time, they still have a time. Things still move forward, but it's not like ours in tiny little increments that everything is related to everything else. It's kind of bigger steps. So every virtual reality has its own clock that it runs by, its own rule set. But these all have to be at a frequency or at a rate, or the delta t has to be such that it's bigger. The delta t has to be bigger. The frequency has to be smaller than the primal clock, than the fundamental clock. Can't be bigger. The fundamental clock's got to have the highest frequency, the smallest delta t. Other than that, they can go down. So let's say the system that is computing us in this virtual reality, it has a whole lot of cycles between our delta t's. It can say every billion cycles that I have, I'm an increment delta t in the simulation once. And another billion cycles, I'm an increment delta t in this simulation once. So here our simulation is crawling along, and it only does one increment for the computer that's calculating us, has billions of cycle times. Well, that gives it a real big advantage, doesn't it? We're like slow motion. So if we see a trend building or something going on or something has to change or probabilities change, it's got a lot of time to calculate, plan, get ready, decide what it's going to do. It's not like it has to work real fast to keep up with us. It has lots and lots of computation time between our delta t's, you see. And then we have simulations, and our simulations have to run at a slower clock than our delta t, you see. And inside those simulations, you can have simulations, but they have to run at a larger delta t or whatever. So that's kind of the way all of that works. But time then keeps ticking. There's all these different clocks going at different rates for different things, but every one of them is ticking away in a linear progressive time because time is fundamental. And I think the concept about all time, there is no time, everything happens simultaneously, that idea, I first ran into that idea in Seth Speaks. And I think that's kind of the origin of that thing, and it spread far and wide. And I think what happened was that Jane misunderstood what she got from Seth. And I think Seth was talking about the databases. In the databases, the future database, There's past databases. There's all the stuff that ever happened in databases. They're all there. It's like a big history book, right? In a history book, you can page forward, you can page backward. They're all in the book at the same time. Everything is there all at once. The future, the past, the present, it's all one. And I think Seth was trying to make that point about the information and the way it worked. And I think Jane took that information and came out with, there is no time, everything's simultaneous. Well, it kind of seems that way, and you can see how that would be an easy mistake to make. And ever since Seth wrote that, I've run into people who said, there is no time, it's all simultaneous. We have all these, the many worlds theory. We have all these different worlds, and every time something changes, that makes a new world, see? And we just jump from, when we go into these other realities, we're just jumping from world to world to world in this nearly infinite array of universes. Well, that theoretically could possibly work, but practically, it's crazy. The reason it's crazy is that you have to duplicate a whole universe because somewhere an electron changes its flip. Because somewhere I scratch my head with this hand instead of with that hand. Oh, a whole universe. Wow, I'm powerful. I just did this. A whole universe gets created, you see. There's all these trivial things. See, the scientists boxed themselves in a corner here. They thought this would get them out of the non-locality thing. Oh, yeah, there's all these physical universes and you just jump around and that's the non-locality solved, and that's the many worlds theory in quantum mechanics. Okay? But they backed themselves into a corner because in order to do that, you have to create the whole universe for every change. But not just every significant change. It's not like you could skip whether I scratch my head with one hand or the other or an electron flipping over, because then you'd have to have some overbeing decide what sort of change is one big enough to make a new universe and which one is too trivial. And that would require judgment on what's trivial and what's not. And that got them right back into metaphysics and religion, and they couldn't go there. So the only option they had was every change. Because if it's not every change, then you have to decide what change. So they were stuck. They painted themselves in a corner. It had to be every change. And now it got ridiculous. Every elementary particle changes state, and we have a whole new universe. You know how elementary particles we have? You know how often they change state? You know how many universes you'd have to generate to keep up with that? It's just, as far as computation goes, it's impossible. It's not even geometric. It's just unimaginable how fast that grows, because every time, if you had just one, you'd create billions in a second. And then every one of those billions would create billions in a second. And it just keep going like that. And it doesn't take very long before it just doesn't make any sense anymore. So the many worlds has a problem with being practical, not a theoretical problem. Theoretically, sure, you could do all that, but nobody would really run a reality that way. It's not reasonable. It doesn't make any sense is the problem. So yes, we have time, and the time continues to click along linearly, although not at the same rate everywhere. They all go back to kind of the fundamental clock that's the center of consciousness, and everything doesn't happen. Everything that is going to happen hasn't already happened. If the future's all done too, that's another deterministic thing. Science likes that because they like determinism. If you have determinism, that means everything has to obey your equations. Nothing goes outside. That's Newton's view of the big clockwork universe. And they like that idea. So science clings to materialism and determinism, but it creates some philosophical problems for them that they just can't get over. So that's a problem. But I hear that a lot, and there's probably dozens of people here that have heard that too. There is no time. It all happens together. And it's almost, I've heard it so much that I think it's kind of part of our culture now. It's that way, but it doesn't make any sense to be that way. It just doesn't compute to be that way. You can't have consciousness like that, and here we are. Here's consciousness. It's impossible, you see, if there's no change. If there is no time, then you have fake time. Well, what's fake time? Is it virtual time because of things being incremented? Well, yeah, okay, that's what we got. And that's somehow not real time. So we're back to that definition of what's real and what isn't. Well, you find out that it's not that real reality is this and virtual reality is something that's kind of made up. It's kind of fake. It's not like that. This is as real as it gets. This is a virtual reality. We're getting data streams, and it doesn't get any more real than this. We're consciousness. We're fundamental. There is nothing more real. So yes, entirely, it's like Buddha said, it's all an illusion, but it's a real illusion. It's as real as it gets for us in experience. Okay, there's the mic.
On that note, we have to wrap up.
Oh, really? We're having so much fun.
Thanks everyone for coming, obviously. Thanks Tom and Pamela for coming and taking time out of their busy schedules to come to Boston. And big thanks to all the organizers, especially Linda and Bob's not here. Everyone really put a lot of work into this to make it happen. Thanks again for coming, and we'll take it. Tom can take it over.
Thank you.